welcome to Mrs. Park's Algebra 1 class. This is Chapter 8, Section 6, Quadratic Equations, Perfect Squares. So in the previous section, we learned about difference of squares. So today we're going to learn about perfect squares. Okay, so why? If you have a situation like this where you're on a rooftop, in a vacuum, a feather and a piano would fall at the same speed or velocity. To find about how long it takes an object to hit the ground if it is dropped from an initial height of h0 feet above ground, you would need to solve the equation 0 equals negative 16t squared plus h0, where t is time in seconds after the object is dropped. Okay, so when we are factoring perfect square trinomials, it'll look like this. Okay, if you have a squared plus 2ab plus b squared. Okay, only when you have something that looks like this, we can factor it out by saying a plus b times a plus b, which is a plus b squared. If you have subtraction here, so we learned in the previous chapters that if you have this, you can write it out to be this. Now we're going to do the other way around. We're going backwards. So if you have a squared minus 2ab plus b squared, that's the same as saying a minus b times a minus b, which is a minus b squared. Examples you have here. Okay, in this case, your a is 1. Okay, and you have 2ab. So what is your b? You figure out that's 4 squared. So your b is 4. 1 times 4 times 2. So 2 times AB is 8. So there's your A and B. So A is 1, B is 4. Then you can say it's 1x plus 4 times 1x plus 4, which is x plus 4 squared. Okay, here again your A is 1 and your B is 3, because that's 3 squared. Okay, so you can say 1x minus, this time it's minus, so 1x minus 3 squared. Okay. Recognize and factor perfect square trinomials. Determine whether each trinomial is a perfect square trinomial. Write yes or no. If so, factor it. Alright, so is the first term a perfect square? So this, okay, that's going to be, so 4y squared. Yeah, because 2y squared is 4y squared. So yes, it's a perfect square. Is the last term a perfect square? Yeah, because it's 3 squared. So yes. Is the middle term equal to 2 times a times b? So 2 times 2y times 3. So 2 times 2 times 3 is 2 times 2 is 4, times 3 is 12. Y. So is that the same here? Yes. So since all three conditions are satisfied, 4y squared plus 12y plus 9 is a perfect square trinomial, where you can express it as this is the a and this is the b. So when we rewrite this, when we factor it, it's going to be a plus b squared. Okay, that's the a part and that's the b part. Okay, so that's your completely factored form. Alright, let's try another one. B. Is the first term a perfect square? Yes, because that can be rewritten as 3x squared. Okay. Is the last term a perfect square? Yes, because that can be written as 2 squared. So this is your a and that's your b. So is the middle term equal to 2 times 3x times 2? So 2 times 3x is 6x times 2 is 6x times 2 is 12. It's 12x. And that's not a 12x. So no, it is not. So it is not a perfect square trinomial. So just write no and move on. Here's your turn, numbers 1a and 1b. Go ahead and take out that paper and factor those two. Okay, again, I will write for you here. If you have ax squared plus 2ab plus b squared. That can be factored as a plus b squared. Now if it's a minus, then you just put a minus here as well. Okay, so go ahead and pause the video and do numbers 1a and 1b and come back when you're done. Okay, welcome back. Alright, so here's a concept summary. Here's some factoring methods. Alright, first thing you do, you factor out any greatest common factor. Okay, and this doesn't matter how many terms you have, you just factor out the greatest common factor. Here you see that they have all 2x in common. So factor out, take out the 2x, and you have 2x squared. Take out 2x here, you're left with 1x. Take out 2x here, you're left with negative 3. So minus 3. Okay, here's your factor by doing your greatest common factor. Step 2, check for a difference of squares of a perfect square trinomial. Okay, so if you're able to, okay, there's difference of squares. Okay, remember, difference of squares is when you have a squared minus b squared. You can rewrite as a plus b, a minus b. Okay, so here you have 3x squared. This can be written as 3x squared minus 4 squared. So it can rewrite 3x plus 4, 3x minus 4. Okay. And for here, you have, this can be written as 4x squared. Let me write it in different colors so you can tell the difference which one I'm doing. You have 4x squared. Oops. And you have 3 squared. There's your a and b. Okay. And 3 times 4 is 12 times 2 is 24x. Okay, so here's your a and here's your b, so a plus b squared. Okay. Step 3. Apply the factoring patterns for x squared plus bx plus c or ax squared plus bx plus c, general trinomials, or factoring by group. Okay. So in this you may have 3 or 4 terms. Okay. So what you need to do here is you're just factoring until you can't factor anymore. For like this example here, you have 12y squared plus the 9y, 8y plus 6. Okay. And here you can see that they have 3y in common, so they factor out the 3y. What's left? 4y plus 3. And now you can see they have 4y and 3 in common, so factor out that, and you have 3y plus 2 left. And that's your completely factored form. Okay. Alright, here's another example. You must make sure that you completely factor each term. Alright, so factor each polynomial if possible. If the polynomial cannot be factored, write prime. So if it can no longer be factored, it's called prime. Okay, just like when you talk about prime numbers, like 3, 5, 7, those are numbers that you can't divide anymore. So, alright, so you have 5x squared minus 80. The greatest common factor of those two terms is 5. So factor out the 5. So if you take out the 5, you have what do you have left? X squared minus 16. Because 16 times 5 is 80. Alright, here we go. So the 5 stays out. Okay, I see here it's x squared and 4 squared. So this is x squared minus 4 squared. Now you have difference of squares. So can we write this as x plus 4 and x minus 4? So 5 times x plus 4 and x minus 4. Okay, so that's your completely factored form. Okay, so let's move on to example B. Alright, so greatest common factor, what do you have? What do they all have in common? It looks like they don't have anything in common, so the greatest common factor is 1. So we're not going to factor out any numbers here. Next, what we're looking for, do they have any perfect squares? 3x this is the first term is perfect square. 35 is not a perfect square. So it's not a perfect square trinomial. Okay, then what do? All right, let's look at the pattern. Ax squared plus bx plus c are the two numbers. So if you remember from the previous sections, I'm not sure which section it was, but when you have product, okay, when you have product of, multiply these two numbers, okay, product of 315, or sum of negative 6, then you can factor out. Okay, so what two numbers do you multiply to get negative 315? Okay, so here you have 15 times 21. Okay, so 15 times negative 21 equals negative 315. And when you add these two numbers, 15 plus negative 21, that does in fact equal negative 6. So those are the two numbers that we're looking for. That means this here is going to equal to here we go, 19. Okay, so we're going to regroup. So remember, there are two ways that you can do this. If you want to do the textbook way, which is what they did, is regrouping. Okay, so that means they have 15x and negative 21x. So all we did was regroup those, and we have 9x squared plus 15x plus negative 21x minus 35. Okay, here you can factor out the 3x, and here you factor out the negative 7, and you can see that they have 3x plus 5 in common. So 3x plus 5 comes factored out, and what's left is the 3x minus 7, and that's your factored form. Okay, so here you can see it's really combining all the factoring strategies that you've learned and just see which one actually you can apply to this one. Okay. So this was a hard one. If you want to take a second to pause the video and look over the steps again, okay, to review, I think that would be a great idea. Okay, if not, let's move on. Here's your turn 2A and 2B. So make sure you completely factor these to make sure you completely factor the terms out until you cannot factor anymore. Okay, if you want to go back to the video, rewind and look at the steps 1, 2, 3. Okay, first you need to find the greatest common factor if they do have any, in fact. Okay, see if they're perfect squares, and look at the different forms that you can factor out. Alright, solve equations with perfect squares. When solving equations involving repeated factors, it is only necessary to set one of the repeated factors equal to 0. Okay, so you want this to look like equals 0. So you added 64 on each side. Okay, made it look equal 0. So here we're going to factor all this. Okay, so is 9x squared. First thing we look at is, do they have anything in common? So it looks like they don't. So they don't have a greatest common factor. So we're going to see if this is a perfect square and this is a perfect square, which they are, because 3x can be squared and 8 can be squared. Okay, and when you have a times b times 2, it does in fact equal negative 48. Alright, so here you have you have 3x and you have 8. So that's your a and b. So now you have a minus b squared. Okay, and that can be rewritten actually as 3x minus 8 times 3x minus 8, which means if that equals 0, and because they're identical, 3x minus 8 must be 0. So if you solve for x here, you add 8 on each side and then divide by 3, so your final answer is x equals 8 over 3. Okay, so here's your turn 2A and 2B. If you're not sure, rewind and look back at this example here. Your goal is to make it equal 0, factor it out, and then solve for your x. So go ahead and do numbers 2a and 2b. Okay, welcome back. Solve equations with perfect squares. When solving equations, wait, we just did that one. Okay. Whoop. Oh, we just did that one. Okay, so let's go on and do 3a and 3b. You're still factoring completely until you cannot factor anymore. This one asks you to solve for a, and this one you're solving for y. All right, reading math, square root solutions. If you see something that looks like this, it's read as plus or minus the square root of 16. So there's two possibilities. It can be a positive square root of 16 or a negative square root of 16. You have solved equations like x squared minus 16 equals 0 by factoring. You can also use the definition of a square root to solve the equation. So you can do this by factoring, or you can say x squared equals 16. When you have a square, you can say x is going to equal square root of, well, there's going to be two possibilities. It can be positive or negative. So plus or minus square root of 16, okay, which is square root of 16 is 4. So your answer can be expressed as plus or minus 4. Okay. So to solve a quadratic equation in the form x squared equals n, take the square root of each side. For any number, n is greater or equal to 0 if x squared equals n, then x equals plus or minus square root of n. For example, if you have x squared equals 5, then you have x equals plus or minus square root of 25, which is equal to plus or minus 5. Okay. Because you have to remember 5 squared is 25. Also, when you do negative 5 in parentheses squared is also 25. That's why we had that plus or minus sign there. Okay. In the equation x squared equals n, if n is not a perfect square, you need to approximate the square root. Use a calculator to find an approximation. If n is a perfect square, you will have an exact number. So for numbers like 25, okay, the square root of 25 is a perfect square because that comes out to be 5. But if you have a number that's not a perfect square, then you'll have to use a calculator to give an estimate. So for example, you have here, okay, this squared equals 81, so that means y minus 6 is plus or minus square root of 81, and square root of 81 is plus or minus 9, and you have y equals 6 plus, because you added 6 on each side, you have 6 plus or minus 9. So there's two possible solutions here. It can be 6 plus 9, or it can be 6 minus 9. So there's two separate solutions. Y can be 15 or negative 3. So roots are 15 and negative 3. So you have two answers here. All right, example B. Let's try another one. So if you want to get rid of the square, you're going to square root the 12. Okay. So x plus 6 is square root, plus or minus square root of 12. Now you have x equals, you're subtracting 6 on each side, so you have x equals negative 6 plus or minus square root of 12. All right, the roots are negative 6 plus or minus square root of 12, which you have two possibilities, plus or negative. So negative 6 plus square root of 12, negative 6 minus square root of 12. Use a calculator, okay, because 12 is not a perfect square. So if you use a calculator, it'll give you some decimals here, and you just round it up to your tenth or hundredths, whatever they ask you to do. Okay, here's your turn, 4A and 4B. This is the last slide. I know this has been a long lesson. I apologize, but we had to cover everything. So go ahead and do this and then put this away for your homework. Okay, thanks for watching.